All right, today we are expanding on our work with radians. And the focus today is kind of what we led into at the end of last class, where we're going to convert back and forth between radians and degrees. And let's just remember that if we have an angle, okay, this angle can be measured in either using units of degrees, let's say 45 degrees, or if we wanted to, we could measure that angle in what's called radians. And in that case, if it was 45 degrees, we'd have pi over 4 radians. And either way, we're describing an angle. So our formula for converting from radians to degrees, if we're given radians and want to find degrees, we're going to use the formula in this box here. And that's already on your note sheet. So what we want to do is write these 3 steps that are located to the right of that box, just so we can look back and remember how to do this. So first thing we do, we plug radians into the formula, then we cancel out the pi's, and then we can calculate. Let's try it out on example 1, 2 pi over 3. So we know what the radians are, so we're going to rewrite our formula here. And I'm going to abbreviate degrees as DEG. So degrees equal whatever our radians are. In this case, our radians are 2 pi over 3 times 180 over pi. So we've plugged radians into our formula. Now we can cancel out the pi's because we have one up top and one on bottom. And then we can calculate just by multiplying across, right? We have 2 fractions multiplied by each other. So we have 2 times 180 divided by 3. We have a nice handy dandy calculator here that's going to tell us that that is 120 degrees. And let's finish out that problem just by putting a box around our answer, making sure we have that degree symbol notating the units. All right, if you've got a good grasp on this, I'd say go ahead and pause your screen. Try this out on example 2. We're just going to do the same thing. When you finish the problem, unpause it, come check it against mine. But we have 7 pi over 6 radians, so I'm going to rewrite that into our formula. We get the degrees are equal to our radians, which again I'm going to use as blue. 7 pi over 6 times 180 divided by pi. In this case, we can cancel out the pi's again, and we'll get 7 times 180 divided by 6. And if you don't want to rewrite that step, that's totally fine. So 7 times 180 divided by 6, I plug into my calculator, and we're going to get 210 degrees for our answer. We are also going to work in the other direction today. Oftentimes we'll get degrees and we want to turn that into radians. So again, this is in the next section of your note sheet. We have the formula already written in our box here. I wrote it in a little different format than we saw on Tuesday just to help us out, make things a little visually easier. So let's write down these 3 steps. Plug degrees into our formula. Expand to help us simplify. We'll kind of recall that skill in a second here. And then we're going to leave pi in our final answer. This step number 2, the expanding, that's going to take some practice. And this is by far a more difficult skill than what we just did. So if we have 120 degrees, we're first going to just plug it into our formula like we did before. This time we have radians. I'm going to abbreviate that as RAD equals our degrees, which is 120. That goes on top of our fraction, times pi divided by 180. So we've plugged degrees into our formula. And now we want to expand out just like we did with rational expressions earlier. And the thing I'm going to expand out for is I'm going to, on top, change 120. I'm going to change it into 10 times 4 times 3 times pi. And I got that by looking at 120, noticing that there's a 0 at the end, so I can divide out a 10 if I want to. And then we can focus on, all right, We have 12 left over. And what can multiply together to get to 12? Well, it's 4 times 3. Then on the bottom here, let's try to expand out in a similar fashion, all right? So I'm going to start with the idea of 10 times 18. And we're probably going to need to break down 18 even further, so let's erase that. And we can break that down into 6 times 3. Okay, and we're starting to hunt for things that show up on both top and bottom. And I see I have a 10 here that we can cross out. Cool. On both top and bottom, there's a 3 on both top and bottom we can cross out. And we're left with 4 pi over 6. However, I can simplify that even further. It looks like I probably could have expanded that 4 and that 6 out further in that last step. So it's taken a little guess and check here, but if I rewrite that again, okay, 4 we can expand out to 2 times pi. 6 we can expand out to 3 times 2. Okay, I'm going to cross off those 2's on top and bottom and just get left with 2 pi over 3 as our final answer in radians. It will take some guess and check here, so the practice is really going to come in that second step. So if you're watching, I'd encourage you to try this on your own for example 4. I'm going to run through the steps again. So we have 210 degrees. Let's use our formula. Radians equals our degrees, 210 times pi over 180. I'm going to expand out, and it looks like both these numbers, 210 and 180, have a 0 at the end, so I know I can take a 10 out of both of them. So I have 10 times, and I'm looking for 21 here. So the only combo that can hit 21 is 7 and 3. So 10 times 7 times 3 times pi up top. Now let's try that same thing we did with 180 before. We have 10 times 6 times 3 on the bottom there. And this one looks like it's going to work out pretty clean. All right, I have 10 that I can cross up top and bottom, 3 I can cross out on top and bottom, and I'm left with 7 pi over 6. And let's just think about it. Can I break 7 down further? No, it's just 7 and 1. So that can be our final answer, 7 pi over 6 radians. All right, let's do one more problem. This one just a little trickier because we don't have a 0 at the end of our degrees, so our breakdown has to be a little different. We have 45 degrees here. We're going to rewrite our formula. So radians, RAD, equals the degrees, which was 45, times pi over 180. So if we expand this out, let's think up top. We have 9 times 5 gives us 45. And right off the bat, I know, hey, I can break down 9 further. So I'm going to erase that quick and change that to 3 times 3. So we want to break those numbers down as low as possible. And then I still have my pi at the end. And then 180, I know I can take out that 10. And I can do times 6 times 3. But again, let's try to break these numbers down as far as possible. 10, I can break down into 5 and 2. So let's erase that, throw that as 5 times 2 there. And that 6 I can also break down into 2 and 3 if I wanted. So let's erase that real quick and change that to 2 times 3. And that's the thing I like to do is I like to work with pencil. I like to kind of break it down in steps, erase, update those. Now that I've got it broken down to the smallest numbers, I'm looking for pairs I can cross out. We have a 3 on top, 3 on bottom, another 3 on top with another 3 on bottom. We got that 5 on top and on bottom. And so what this leaves us is just a pi up top divided by 2 times 2 on bottom, which is 4. And if you wanted to, I mean, this is our final answer right here, pi over 4. If you wanted to, however, we could tack a 1 in front of that pi, just like you sometimes tack a 1 in front of that x, right? If you have 1 of something, you have, you can either leave the coefficient 1 in front or leave it blank.